rules of limits.
Hey guys, in this video we are going to talk about calculating limits using the limit law. First, we're going to talk about the special limit. Now, for the limit of a constant function, y is always equal to c. It doesn't matter what x approaches. It is illustrated as the limit of c as x approaches c is equal to c.
For example, the limit of 8 as x approaches 6 is equal to 8.
Next, for the identity function. It deals with the function y is equal to x. Since y and x are equal, whatever value x approaches, y will have to approach the same value. It can be illustrated as the limit of x as x approaches a is equal to a.
For example, the limit of x as x approaches 4 is equal to 4.
Now, we are going to talk about the basic limits. The first one under the basic limits is the sum law. Here, it is stated that we can take the limit of each term individually, then add the results. It can be shown as the limit of f of x plus g of x as x approaches a is equal to the limit of f of x as x approaches a plus the limit of g of x as x approaches a.
For example, the limit of the quantity of x plus 5 as x approaches negative 7 is equal to the limit of x as x approaches negative 7 plus the limit of 5 as x approaches negative 7, which is equivalent to negative 7 plus 5 or negative 2.
The next one is the difference law, which is basically the same as the sum law, but now we have to subtract the results. It can be illustrated as the limit of f of x minus g of x as x approaches a is equal to the limit of f of x as x approaches a minus the limit of g of x as x approaches a.
For example, the limit of the quantity of x minus 9 as x approaches 1 is equal to the limit of x as x approaches 1 minus the limit of 9 as x approaches 1, which is equivalent to 1 minus 9, which is equal to negative 8.
For the third one under the basic limits is the constant multiple law, where it states that if a function has a coefficient, you take the limit of that function and multiply it by the coefficient.
For example, the limit of 8x as x approaches 3 can be found by calculating 8 times the limit of x as x approaches 3, which is equal to 8 times 3 or 24.
Now for the product law. If the function involves two or more factors, you can take the limit of each factor and multiply the results together. It can be shown as the limit of f of x times g of x as x approaches a is equal to the limit of f of x as x approaches a times the limit of g of x as x approaches a.
For example, the limit of x squared as x approaches 5 is equal to the limit of x times x as x approaches 5, which is equal to the limit of x as x approaches 5 times the limit of x as x approaches 5, which is equivalent to 5 times 5 or 25.
Now for the fifth is the cogent law, where it states that we can find the limit of the numerator and the denominator separately, as long as we don't get 0 in the denominator. And it is shown as the limit of f of x over g of x as x approaches a is equal to the limit of f of x as x approaches a over the limit of g of x as x approaches a.
The limit of 2x over x minus 4 as x approaches 3 is equal to the limit of 2x as x approaches 3 over the limit of x minus 4 as x approaches 3. That is equal to the 2 times the limit of x as x approaches 3 over the limit of x as x approaches 3 minus the limit of negative 4 as x approaches 3, which is equal to 2 times 3 over 3 minus negative 4, and the final answer is 6 over 7.
Now for the power law. You can take the limit of the function first and apply the exponent. But if the exponent is negative, then the limit of the function can't be 0. It is shown as the limit of f of x raised to n as x approaches a is equal to the limit of f of x as x approaches a raised to n.
For example, the limit of x plus 1 cubed as x approaches 4 is equal to the quantity of the limit of x plus 1 as x approaches 4 cubed, which is equal to the quantity of the limit of x as x approaches 4 plus the limit of 1 as x approaches 4 cubed. And that is equal to the quantity of 4 plus 1 cubed, which is 5 cubed or 125.
Lastly, for the root law, you can find the limit of the inside function first, then apply the root. It is illustrated as the limit of the nth root of f of x as x approaches a is equal to the nth root of L, or the limit.
For example, the limit of the square root of x plus 18 as x approaches negative 2 can be found by acquiring the limit of the quantity of x plus 18 as x approaches negative 2. Then, the square root of the limit of x as x approaches negative 2 plus the limit of 18 as x approaches negative 2 is equal to the square root of negative 2 plus 18, which is equal to the square root of 16. And the final answer is 4.
Thanks for watching!